Welcome to another Midnight Voyage, a space where science becomes story and story becomes serenity. As the world grows quiet and the stars begin to hum above us, you found your way to a place between waking and sleep. A place where curiosity can drift freely and time moves like a slow tide. Each journey we take here will guide you through the deep past, across the cosmos, and into the inner workings of reality itself. Sometimes we'll wander through the formation of planets. Other times we'll glide along the fabric of space-time, or walk quietly through the footsteps of history. But no matter the destination, the path will always be gentle, mindful, and crafted to help you relax, reflect, and, if you wish, sleep. Before we begin tonight's voyage, I'd love to know something about you. What part of science sparks your imagination the most? Where in the world are you listening from tonight? And just out of curiosity, what time is it where you are right now? Midnight, 3 a.m., or early morning just before the birds sing? Feel free to share your thoughts in the comments and connect with fellow voyagers. This channel is not just a broadcast, it's a community of quiet travelers, each on their own journey. So take a deep breath, settle into your pillow or your chair, let your eyelids soften, and now, let yourself drift. Together, we begin tonight's Midnight Voyage. Tonight, we drift across eons to witness the formation of Earth, from the first spark of the universe to the cooling of molten oceans to the very breath of life itself. This is not just a story, it's a journey through deep time, told in a calm, quiet voice, meant to soothe you into rest. Whether you're settling in for sleep or just letting your mind unwind, you're in the right place. And let's begin our first chapter, where everything began. Chapter 1. Birth of the Universe. Before there were stars, before there were planets, before even time had a name, there was silence. Let that silence surround you now. The kind of silence that stretches beyond all thought, all motion, all form. There was no light, no darkness even, no space to fill, and no matter to move within it. There was only stillness, and then everything changed. In a moment beyond time, the universe was born. We call it the Big Bang, but that phrase can be misleading. It was not an explosion, not a blast in space, for there was no space yet. Instead, space itself unfolded. Time began its slow and patient march. All energy, matter, space and time surged outward from a point smaller than a grain of sand. A singularity, so dense, so hot, so concentrated, that even the laws of physics struggled to define it. From that point, the universe expanded in every direction, not into space, but creating space as it expanded. Let that idea settle in your mind now. A universe not expanding into the dark, but bringing darkness with it. The fabric of reality stretching like a soft breath across nothingness. This moment, this origin, is the womb from which everything was born. Every star, every ocean, every mountain, every cell, every thought, even you. You were there in a way. Your atoms were not yet formed. But the raw ingredients of your being were drifting in that original fire. Let's stay here a while. In this newborn universe, in the first seconds, temperatures soared beyond imagination. Trillions of degrees, energy condensed into particles. The first building blocks of matter appeared. Quarks, electrons, neutrinos. They danced in a dense soup of pure energy, colliding, annihilating, and reforming. Quarks joined to form protons and neutrons. These were the seeds of all atomic nuclei. Within minutes, these particles began to bind together, forming the very first elements. Hydrogen, a bit of helium, traces of lithium. But the universe was still far too hot for atoms as we know them. Electrons were not yet bound to nuclei. For the next 380,000 years, the universe remained a glowing, hot fog of unformed atoms. Light was trapped, bouncing endlessly off charged particles, unable to travel freely. And then, as the universe expanded, it cooled, gradually, relentlessly, until at last it was cool enough for electrons to settle into orbits around nuclei. The first atoms formed. The universe became transparent, and for the first time light was free. It streamed outward in all directions, filling the cosmos with a soft golden glow. That light still echoes today. We call it the cosmic microwave background, a faint hum of radiation, gently pulsing through the fabric of space. It is the whisper of the beginning, still singing its lullaby billions of years later. If you could close your eyes and hear the universe itself, you would hear that hum, soft, even, endless. The light of the first moment, still shining. Let yourself float in that glow now. Weightless, timeless. You are surrounded by hydrogen and helium atoms, drifting in silence. The universe has cooled, but it is still young and almost entirely empty. No stars yet, no planets, no structure, but gravity has begun to stir. Even now, gravity, the quiet sculptor of the cosmos, has begun its patient work. Tiny variations in density, smaller than grains of sand, begin to pull matter together. Clouds of gas collapse under their own weight. They begin to spin, to compress. And from that compression, stars are born. The first stars ignite like sparks in the void. Massive, unstable, brilliant. They live fast and die young. Some explode as supernovae, colossal blasts that rip atoms apart and forge new ones. These are the furnaces of creation. Inside their cores, heavier elements form: carbon, oxygen, silicon, iron, the raw material for planets, the raw material for life. When these stars die, they scatter those elements across space, enriching the universe with the seeds of complexity. The atoms in your body, your blood, your breath, your bones, were forged in these ancient stars. You are not just in the universe. You are the universe, remembering itself. And slowly, across billions of years, stars gather into galaxies. These are vast cities of light, each galaxy home to billions, sometimes trillions of stars, and in one quiet arm of one quiet spiral galaxy, a cloud of gas and dust begins to swirl. This is the Milky Way. This is our home. That cloud, our solar nursery, waits in silence. It will collapse. It will form a star, and from that star, a family of planets. But not yet. For now, let us linger in this soft darkness. The stars have formed. The galaxies have begun their rotation. The universe has taken its first breath and found its rhythm. Let your breathing match that rhythm now. Slow, steady, quiet. You are floating among hydrogen atoms that will one day form oceans. You are drifting past iron that will one day flow in your veins. You are among stars not yet born and suns already gone. This is the cradle of everything. Let yourself rest in it. Time is long here. It stretches across unimaginable spans, from the Big Bang to stardust to starlight to stone. All of it guided by one hand, gravity. Not a loud force, but a constant one. It shapes without sound. It builds without permission. It waits. And in that waiting, it creates. Let that stillness move through you now. You are not in a rush. You are not behind. You are right on time. You are part of this unfolding. Every heartbeat echoes with the rhythm of the expanding universe. Every breath is a thread woven into the story of time. You are not separate from the cosmos. You are its expression. Sleep now, beneath the soft glow of the first light. Let the silence of the ancient universe cradle you. There are no cities here, no thoughts, no past, no future. Only now, only motion, only the slow turning of a universe becoming itself. And soon, in the next chapter, that motion will bring forth a star, the sun, and around that star, a pale blue world. But for now, drift among the stars. Let the birth of the universe be your lullaby. You are safe. You're infinite. You are home. Chapter 2. Formation of the Solar Nebula. The universe has grown older now. Nearly 9 billion years have passed since the first light flickered across space. In that time, countless stars have lived and died. Galaxies have swirled like cosmic snowflakes. and gravity has continued its quiet work, pulling, shaping, sculpting. And somewhere, in one quiet arm of the Milky Way, a cloud waits. It floats in the galactic dusk, cold and dark, full of promise, a molecular cloud, vast, silent, and ancient. It stretches across trillions of miles, filled with hydrogen, gas, helium, and dust particles made from shattered stars. Within its heart is chaos and calm, swirling in silence. This is where the story of our solar system begins. Now, something changes. Perhaps it's a shockwave from a nearby supernova, a ripple of energy that stirs the stillness. Or perhaps it's simply gravity, growing stronger over time, folding space in on itself. Whatever the trigger, the result is profound. The cloud begins to collapse. Slowly at first, like a breath drawing inward. As it collapses, it begins to spin, ever so slightly. And as with a figure skater drawing in their arms, the spin quickens, faster and faster. The once amorphous cloud flattens into a disk, a wide, thin, spinning platter of dust and gas. At the centre, the pressure rises. Material piles in, pressing down, growing hotter and hotter under its own weight. This is not yet a star, but it dreams of becoming one. The temperature at the core of this growing mass climbs to millions of degrees. And then, the miracle. Hydrogen atoms begin to fuse. Two become one, releasing energy in the process. A new star has been born, our Sun. It blazes to life in a burst of nuclear fusion, casting light and warmth into the swirling disk around it. But the story doesn't end here. In fact, it's just beginning. Around the Sun, within the protoplanetary disk, tiny grains of dust begin to stick together. Static charges, gentle collisions, slow accretion. These grains form clumps. The clumps become pebbles. Pebbles become rocks. Rocks become boulders. And with time, gravity becomes king once again. The larger these bodies grow, the more they attract other material. What was once dust now becomes planetesimals, small worldlets, hundreds of kilometers across. They orbit the Sun in broad elliptical paths, like dancers swirling around a bonfire. Some of them collide gently, others shatter in violent crashes, but over millions of years, the larger ones dominate. They clear their paths of debris, absorbing or deflecting smaller bodies. In the inner disk, close to the Sun, it is too hot for gases to condense. Here, rocky worlds are forming. Small dense planets made of metal and silicate begin to emerge. These are the seeds of Mercury, Venus, Earth, and Mars. Farther out in the colder reaches of the disk, ices and gases cling together more easily. Here the gas giants, Jupiter and Saturn, begin to grow massive. They gather thick atmospheres of hydrogen and helium. Beyond them, Uranus and Neptune collect ices and gases, becoming icy giants of their own. But let's return to the inner disk, where a special world is forming. A world that will one day harbour oceans, life, and memory, Earth. At this stage, Earth is just a growing embryo of rock, still molten, still battered by constant collisions. It has no atmosphere, no oceans, no moon, just heat, pressure, and motion. Its surface is a hellscape of volcanic activity and raining meteors. But deep inside, things are stirring. Heavy elements like iron and nickel begin to sink to the centre. Lighter materials float outward. This process, called differentiation, will shape Earth's internal structure, its core, mantle, and crust. But that comes a little later. For now, Earth is still gathering mass, still growing through a process called accretion. Each impact adds more material. Some are small, a quiet sprinkle of dust, others are cataclysmic. Planetesimals the size of cities crash into Earth, releasing more energy than thousands of nuclear bombs. These impacts melt surface rock, sending vapor into space, and carving scars across the young planet. But each impact is part of the planet's formation. Each one helps define its destiny. And the Sun, now stable and radiant, continues to shine, casting light across the growing solar system. Solar winds, streams of charged particles, blow outward, sweeping away leftover gas from the inner disk. The building phase is slowing down. The chaos is beginning to settle. Planets have taken shape. The solar system has formed. But Earth's most dramatic moment is still to come. One final collision will change everything. From it will be born the moon. But before we witness that event, take a breath. Let your mind drift through the disk of dust and gas, drifting around the newborn sun. Feel the warmth from 93 million miles away. See the shimmer of metal and rock in the early light. Know that everything, every mountain, every ocean, every life form began here, in the dust of stars gathered by gravity, shaped by time. And now, let us continue the story. The chaos of the early solar system slowly begins to settle. What was once a swirling cloud of dust and gas is now a delicate cosmic clockwork. 8 planets, dozens of moons, and countless smaller bodies, asteroids, comets, and dwarf planets, all orbiting a quiet golden star. But still, the inner planets are not yet calm. Even though Earth has taken shape, it is far from finished. In these early days, the sun's light is weaker than it will one day become. The young Earth is a fiery world, covered in oceans of molten rock, its surface churning with volcanic rage. Above it there is no sky as we know it. No blue, no clouds, no breeze, only a hazy atmosphere of rock vapour and gas, rising from the constant impacts raining down from space. Earth is still gathering itself, still becoming. But the solar system has no kindness for half-finished worlds, and Earth is about to face its greatest trial. In this newly formed neighbourhood, not all planetesimals survived the Great Merging. One in particular, a Mars-sized object, still roams the inner solar system. Scientists call it Theia. It formed from the same disk as Earth, and for a time it followed a nearby orbit. But gravity, ever the sculptor, had other plans. Bit by bit, Earth and Theia drift closer. Their paths, once separate, begin to converge, and then, in a moment that reshaped our world forever, they collide. The impact is unimaginable. Theia strikes Earth at a glancing angle, releasing more energy than any event since the birth of the sun. Mountains liquefy, oceans of magma are hurled into space, the crust itself is torn asunder, chunks of both Earth and Theia are blasted outward, fiery debris glowing like a second sun. For a moment Earth is no longer one world, but many fragments suspended in space. But gravity, once again, does not rest. Over weeks and months the debris forms a disk around the wounded planet, a ring of molten rock and vapour, orbiting high above the Earth. And from this ring, something new begins to gather. Tiny pieces clump together, small bodies merge, and slowly, gracefully, a new companion is born. The moon, not formed with Earth, but born of trauma, a child of collision and rebirth. The moon stabilizes Earth's spin, slows its rotation, and over time gives rise to tides. Without it, life as we know it may never have emerged. Even now, as you lie in bed, the moon continues its gentle pull on the oceans, guiding the rhythms of life, echoing the cataclysm that forged it. And though the violence of that impact has long since faded, it shaped everything. It tilted Earth's axis, giving us seasons. It thickened our atmosphere, providing warmth. It stirred Earth's interior, setting its molten core into motion. And from that spinning, molten heart, Earth's magnetic field was born, a shield of invisible force, protecting the planet from the sun's harsh solar wind and preserving our atmosphere. Earth, once vulnerable and exposed, now wears a cloak of protection. The surface begins to cool. The oceans of lava slowly solidify into crust. Volcanoes continue to erupt, but the frequency begins to decline. A thin, toxic atmosphere clings to the planet, rich in carbon dioxide, ammonia, and methane. But that too will evolve in time. Above, the sun shines brighter now, stabilizing in its main sequence, burning hydrogen into helium with patient fury. The solar system, once wild and uncertain, is beginning to resemble the familiar home we know. Jupiter's gravity clears the asteroid belt. Saturn's rings begin to glow in the sunlight, Comets from the outer reaches occasionally streak inward, seeding the inner planets with ice. One of them, perhaps many, will eventually bring water to Earth. The ingredients for life are arriving, but that part of the story is still to come. For now, Earth spins quietly, with the moon at its side. The worst of the bombardment is behind it, and yet it still bears the scars. Even today we can see them in the moon's cratered face, silent reminders of a time when the skies rained fire, and the Earth trembled with every hour. But it survived, it formed a crust, it found balance, it held its atmosphere, and it began to wait. Wait for oceans, wait for chemistry, wait for the first spark of life. The solar system has taken its shape, and Earth at last has found its place in the great cosmic dance. Let yourself imagine that dance now. A planet spinning quietly beneath the stars, wrapped in a magnetic field, anchored by a silvery moon, slowly cooling after a violent birth. This is your home, but it has not always been calm, and it will not always remain so. For now, though, the night is peaceful. You are safe. The Earth is cradled in space, exactly where it needs to be. Let your breath slow, your thoughts soften. You are made of the same elements as this world. Carbon from ancient stars, oxygen born in stellar hearts, iron forged in cosmic collisions. You are the Earth remembering itself. Sleep now beneath the light of the moon. The journey continues in the silence of the next chapter. When the crust cools, the rains begin, and the oceans come to life. But for now, rest, and let the rhythm of planetary formation lull you into deeper dreams. Chapter 3: Proto-Earth and Planetary Collisions. The Earth was not born all at once. It emerged, piece by piece, from collisions in the darkness. Let your breath match that rhythm, the slow, endless merging of stone upon stone, guided by gravity's patient hand. In the earliest days of our solar system, the region where Earth now rests was a celestial construction site. Dust, metal, and stone floating in wide orbits around a young sun. These were the building blocks of a planet, and they were everywhere. This era, known as the Hadean, was named after Hades, the ancient underworld. For in these formative days, the Earth was a world of fire. At first, tiny particles of dust clung together, held by static charge, forming grains and then pebbles. Pebbles became boulders, boulders became rocks, and soon these growing rocks crashed into one another with increasing force and size, forming massive planetary embryos. These were the planetesimals, cosmic seeds of worlds, and one of them, somewhere in that inner disk, was becoming Earth. It was not alone. All around it, other planetesimals formed and drifted, each one with its own trajectory, its own fate. Some would merge, some would shatter, and some would vanish entirely, absorbed into larger bodies, never to be seen again. The Earth's early growth was violent yet necessary. Every impact added mass, added heat, added momentum. When two planetesimals collided, their kinetic energy transformed into heat, melting rock, vaporizing crust, forming temporary magma oceans. Over time, these oceans cooled, only to be reheated by yet another impact. It was a cycle of formation and destruction, a cosmic crucible in which the Earth slowly forged itself. Even in the quiet night sky today, this legacy remains. The moon's surface is scarred by craters, footprints of the era when the solar system was still sorting itself out. Earth too bears those scars, but unlike the moon, our planet's surface is alive, shifting and renewing. The rain erases, the wind softens, the crust recycles itself through tectonic motion. Still deep in the mantle, fragments of ancient impacts may yet remain, silent witnesses to Earth's chaotic youth. As the proto-Earth grew larger, gravity began to concentrate its mass towards the centre. This allowed a process called differentiation to begin in earnest. Heavy elements like iron and nickel sank inward, forming the planet's core. Lighter silicates rose to the surface, forming what would become the mantle and eventually the crust. This process generated even more heat. The Earth was alive with fire, Not the fire of flame, but the fire of pressure, of transformation. Volcanoes erupted from countless fractures in the surface, releasing plumes of gas into the sky. Carbon dioxide, nitrogen, water vapour, sulphur. These were the ingredients of an early atmosphere, not yet breathable, but essential. Still, the Earth was far from stable. All around it, other large bodies moved in unpredictable orbits. One of them may have been Vesta, another may have been Theia, whose collision we've already seen. Others were smaller but still dangerous. Some carried water in the form of ice, some carried metals like gold and platinum. All of them, whether they joined Earth or shattered upon impact, played a role in shaping the chemical makeup of the planet. Imagine the sky of this young world, a blood-red haze, the air thick with volcanic ash, comets occasionally streaking across the upper atmosphere before exploding in brilliant flashes. And everywhere the sound of motion, the groaning of tectonic plates still in their infancy, the distant rumble of impacts, the hissing breath of escaping gas. This was not a place for life, not yet, but it was a place of preparation. For what is life, if not the product of chaos sculpted into complexity? One by one the collisions grew less frequent. The largest threats were absorbed or deflected. The Earth began to cool. Its crust thickened, forming primitive plates. The magnetic field generated by motion in the molten outer core began to stabilize. And that field, invisible but powerful, reached out into space like a shield. It deflected solar radiation. It preserved the delicate gases accumulating around the planet. It was as if Earth had donned armour, preparing for its next chapter. And what a chapter it would be, for in the quiet that followed the bombardments, rain began to fall. At first, steam from volcanic eruptions condensed into droplets. Then, as the crust cooled further, it rained harder. For centuries, for millennia, until oceans began to form. But before we dive into those waters, let us linger here a little longer. Let us breathe with the rhythm of a cooling world. The air is still thick, the ground still warm beneath your feet. But for the first time, the surface is beginning to hold its shape. Rocks solidify, mountains rise, seas gather in basins. The chaos begins to yield to form. And in this moment, Earth becomes more than just a planet. It becomes a world, still empty of life, but full of potential. Sleep now and dream of falling stars, of silver moons rising over molten landscapes, of a planet sculpted by collision and cooled by time. Your body, your breath, your very bones carry the memory of these early days. You are made of their remnants, iron from meteorites, calcium from the crust, oxygen from ancient rock. Each of us is an echo of proto-Earth, shaped by the same forces, cooled by the same rains, protected by the same sky. The story is far from over, but for now, rest in the afterglow of fire and stone. The planet has survived its storm of birth. Now it begins to dream of water. Chapter 4. Differentiation. Core, mantle and crust. Let us descend into the heart of the earth, not in haste, but slowly, like sinking gently through layers of time. Breathe in and imagine peeling away the world's outer shell, one layer at a time, uncovering the secrets beneath your feet. We begin at the surface, the crust, a skin so thin it's barely a fraction of Earth's diameter. Yet it is the place we call home. The crust is cool and brittle, broken into massive slabs called tectonic plates. They float upon something deeper, something older, something alive. Beneath the crust, we find the mantle. A sea of rock, not molten but ductile, solid yet able to flow. Here heat moves upward, and with it, matter rises and falls, like slow-motion waves in a vast ocean of stone. And deeper still, we reach the core, a sphere within a sphere, an outer core, liquid, seething with molten metal. And at the very centre, the inner core, solid, dense, hotter than the surface of the sun. All of this, the crust, the mantle, the core, did not appear at once. It formed through a process called differentiation. Let's drift back, billions of years, to a time when Earth was still young, still molten from constant bombardment. Back then there were no layers, only a vast churning ocean of rock and metal. Everything was mixed, but over time, gravity began its quiet sorting. Heavy elements like iron and nickel began to sink. They drifted downward through the molten planet, pulled toward the center. Lighter elements like oxygen, silicon, and aluminum floated upward. And slowly, the Earth began to settle into layers, like oil separating from water, like cream rising above milk. This was the Great Sorting, a planetary alchemy that would define the Earth forever. The iron and nickel gathered at the core, forming a dense metallic heart. Around it, the lighter rock formed the mantle, a vast zone that would one day rise and fall in currents we now call mantle convection. And at the very top, the thinnest layer, the crust began to crystallize. This was Earth's first skin. Thin, fractured, unstable, but it was a beginning. As the planet cooled, this skin thickened, broke, and shifted. The crust was not one solid shell, but a patchwork of floating slabs. And underneath it all, the mantle moved slowly, churning, recycling, shaping the crust above. Even now, this cycle continues. Where two plates pull apart, new crust is born from rising magma. Where they collide, one plate may be forced downward, melting into the mantle below. This constant movement, the slow breathing of the planet, drives earthquakes, raises mountains, opens rift valleys. But why did the inner core solidify? Why is there both a liquid and a solid core? To understand this, we must sink even deeper. As the outer layers cooled, pressure increased toward the center. The immense weight of the overlying rock compressed the core so tightly that despite its scorching temperature, the inner core froze, iron crystallizing under pressure. Solid, unyielding, spinning slowly within the liquid outer shell. This solid core acts like a dynamo. As the liquid outer core churns and flows around it, electrical currents form. And from those currents rises a force field, the geomagnetic field, invisible yet essential. It shields us from solar radiation. It guides the migration of birds. It causes the northern and southern lights to shimmer in the skies. And deep within, it whispers of the molten heart from which it came. Even now, the inner core grows slowly, millimeter by millimeter, as the outer core cools. It's a living history book, recording the planet's thermal evolution over billions of years. But we rarely think of it. We walk upon the crust, feel the breeze, see the sky. We do not feel the planet's internal tides, but they are always there, beneath the mountains, beneath the oceans, beneath your bed. The core pulses. The mantle flows and the crust shifts. It is a symphony of stone and heat, and you are a part of it. Let us now return to the surface, rising slowly from the core, through the mantle's thick stone sea. Imagine that journey, travelling through 1,800 miles of rock, heat radiating all around you, moving upward, toward the world of light. You pass through layers of peridotite and olivine, minerals that rarely see the surface. They are green, glowing with pressure, crystalline in form. As you rise, the pressure lessens, the rock becomes cooler, and cracks appear. At last you breach the crust. You are home, but the world you've emerged into is young. There are no continents yet, only protocontinents, small landmasses drifting atop the mantle like rafts. The crust is mostly mafic, rich in iron and magnesium, dense and dark. Over time, lighter crustal material, what we call felsic rock, begins to form. This rock, rich in silica and aluminum, becomes the foundation of the first true continents. They are small at first, isolated, battered by meteorites, surrounded by ocean. But they are the seeds of the land we walk on today. Africa, Asia, the Americas, all of them began here, drifting, merging, splitting apart, and drifting again. The crust is not fixed, it is alive with motion. Every few 100 million years, the continents gather into a single supercontinent. Rodinia, Pangaea, others lost to time. And then they break apart again. Like breath, in and out, like waves on the shore. This movement, this plate tectonics, is not random. It is driven by the mantle beneath, by the cooling of the planet, by the lingering heat of its formation. Even today, earthquakes remind us that we live on a shifting surface. Volcanoes breathe fire from the deep. Hot springs bubble with ancient heat. We are passengers on a crust that floats above an ever-moving engine. And yet, it feels so still, so peaceful. As you rest now, remember this: the solid ground beneath you is not eternal. It is born, moves, and is reborn. You are not separate from this movement. You are made of minerals that rose from the mantle, of water that came from the deep earth, of carbon once trapped in ancient rock. Every step you take, every breath you draw, connects you to these layers. Core, mantle, crust, the body of Earth, and the body of you are echoes of the same formation. So sleep now, as the Earth continues to turn, as its inner fire burns softly beneath you, as the continents drift silently across time. This is your world, layered, living, and ancient. The planet has found its center, and now it begins to cool just enough for water to stay, for rain to fall, for oceans to bloom. In the next chapter, the sky will open, and the earth will begin to breathe. Chapter 5: The Moon's Formation and the Era of Heavy Bombardment. Look up at the moon. Its surface is quiet now, still, frozen in silence. But it is not merely a beautiful shape in the night sky. It is a time capsule. A scarred and glowing memory of a time when Earth was reshaped by fire. To tell the moon's story is to understand a moment so extreme, so utterly transformative, that it redefined what Earth was and what it could become. Let us go back. Roughly 4.51 billion years ago, just tens of millions of years after the solar system's formation. Earth was still young, partially formed from a process called accretion, where smaller bodies merged to form increasingly massive planetary embryos, and orbiting not far away was one such embryo. Roughly the size of Mars, this protoplanet followed a path near Earth's own. We call it Theia, named after the Greek Titaness, the mother of the moon. Theia may have formed at a stable Lagrange point in Earth's orbit, likely L4 or L5, a region where gravitational forces create stable pockets of co-orbital motion. But over time, gravitational perturbations from other planetary bodies, especially Venus and Jupiter, likely nudged Theia into an unstable orbit. The precise timing and angle are still being modelled today. But one thing is clear: Theia and Earth collided in a giant impact event. This was not a mere collision, it was a planet-altering cataclysm. Theia struck at an oblique angle, estimated between 30 and 45 degrees, at speeds near 10 kilometers per second. The kinetic energy released was equivalent to millions of hydrogen bombs, detonating simultaneously. Much of Earth's outer mantle and crust were ejected into space. Theia's iron core likely merged with Earth's own, increasing Earth's mass and contributing to its large active geodynamo, the molten, convecting outer core that generates our magnetic field. The rest entered orbit. Molten silicate rock, vaporized crust, and impact ejector formed a hot circumterrestrial disk, a ring of debris spiraling around Earth. Temperatures in this proto-lunar disk likely exceeded 4,000 degrees Celsius. It was a storm of rock vapor, molten droplets, and swirling ash. Now pause here and imagine it. A planet in the aftermath of trauma, its crust torn open, its sky dark with silicate vapor, a glowing disk of fire circling the wounded world. And then, something incredible happened. Within that disk, gravitational clumping began. Molten droplets collided, coalesced, merged. This was governed by accretionary physics. The same process that built planets from dust now built a satellite from molten rain. Over the course of weeks to a few years, depending on the model, that disk gathered into a single, spherical body. Still molten, still glowing, but solidifying. The newborn moon. Now here is where science offers a whisper from the past. The moon's composition, its oxygen isotope ratios, its titanium, tungsten, and chromium isotopes are nearly identical to Earth's. This was once a mystery. Why, if the moon formed from a collision with another planet, does it bear almost no chemical signature of Theia? Newer simulations suggest the impact was far more energetic and chaotic than once thought, possibly a vaporizing collision, where both Earth and Theia were liquefied and partially vaporized, forming a mixed disk from which the moon condensed. This is called the synestia model, a short-lived, torus-shaped cloud of molten rock and gas surrounding Earth, from which the moon condensed. And because the materials were so thoroughly mixed, the moon came out with nearly the same composition as Earth's outer layers. So when you look at the moon, you are looking at Earth's reflection, a shard of the planet, set in orbit by violence, and bound by gravity ever since. In those early days, the moon orbited much closer, only about 25,000 kilometers away. It would have appeared 15 times larger in the sky. Its gravitational pull stirred enormous tides, not in oceans, but in Earth's molten rock. These tidal bulges pulled slightly ahead of the moon's orbit, transferring angular momentum and gradually pushing the moon farther away. This process continues to this day, at a rate of about 3.8 centimeters per year. The moon also became tidally locked, rotating at a speed that keeps one face always pointed toward Earth. This is why we see only one side of the moon from the surface. It's not hiding anything sinister, it's just dancing in perfect synchrony. The moon had taken its place in the sky. The Earth had begun to cool, the rains had started, and for a fleeting moment, there was calm. But the universe was not finished with Earth yet. Something far beyond our planet had begun to shift. A quiet rearrangement among the giants, far from the inner solar system, past the orbit of Mars. The great planets, Jupiter, Saturn, Uranus, and Neptune, were on the move. They had not always orbited where they are now. In those early days, the orbits of the giant planets were compact and unstable. Jupiter and Saturn in particular were drifting. And when they reached a special resonance, when Jupiter completed 2 orbits for every one of Saturn's, gravitational forces surged. This resonance didn't just affect them. It shook the entire architecture of the solar system. Thousands of asteroids, icy bodies, leftover planetesimals were destabilized. From the distant Kuiper belt and the dense asteroid belt between Mars and Jupiter, debris began to scatter, and much of it came inward, toward Earth, toward the moon, toward the sun itself. What followed was a storm of stone and ice, a bombardment so intense it may have reshaped the course of life before it even began. This event is known as the Late Heavy Bombardment, or LHB. It occurred roughly 4.1 to 3.8 billion years ago, and for 300 million years, the inner planets were pummeled. Earth, the Moon, Mars, and even Mercury all bore the scars. On the Moon, we see those scars even now. Look up at its face, see the dark splotches, the great circular basins, the cratered highlands. Many of them were carved out during this violent epoch. The Imbrium Basin, one of the largest and most visible features on the Moon, was formed during this time by an impactor likely over 250 kilometers wide. On Earth, such impacts were even more catastrophic. But our active geology has buried most of the evidence. Even so, we find hints. Tiny crystals called zircons, found in ancient rocks in Western Australia, show signs of having survived extreme heat and shock. Their chemistry suggests surface temperatures may have reached thousands of degrees during bombardment events. Some impacts may have vaporized oceans, boiled rock, and plunged the planet into temporary darkness beneath global plumes of ash and gas. Others may have created deep hydrothermal systems, underground reservoirs heated by impact-induced fractures, mixing water with energy and mineral-rich rock. These may have become cradles of chemistry, hubs where life's first reactions stirred, and not everybody that struck Earth brought only destruction. Some carried treasure, carbon-rich meteorites known as carbonaceous chondrites, rained down during the bombardment. Inside them were organic molecules, amino acids, simple sugars, nucleobase precursors, and phosphorus, an element critical for forming DNA and cellular energy. It's possible that life's raw ingredients didn't arise solely on Earth. They may have arrived from the stars and delivered by fire, preserved through impact, mixed into the oceans and left to evolve. Sleep now, with that paradox, that life may have begun not in a quiet Eden, but in the wake of chaos, that the tools for life were forged in violence, and that Earth survived not in spite of it, but because of it. The late heavy bombardment didn't just mark a destructive chapter. It may have been a necessary stage, a cosmic cleansing, a planetary enrichment, a final reshaping before Earth settled into long-term stability. And so the bombardment ended. Slowly, the storm passed. The great planets finished their drift. The skies grew quiet, and Earth bore the memory. Cracks in its crust, molten scars now cooled, oceans once boiled, now calm. The moon, pitted and broken, stood silent witness. And below the surface, perhaps in warm pools of chemical possibility, something tiny and fragile and alive stirred for the first time. Let that image carry you deeper. The fire has passed, the earth still turns, the moon still watches, and you are a descendant of that survival, of that calm after the storm. Sleep now as the last stones fall from the sky, and a quiet world prepares to dream. The moon has long since cooled. Its surface, once rivers of glowing lava, is now frozen in time. Its craters speak softly of the chaos it has endured, but its presence is steady, reliable, watching. And yet, to call the moon a mere companion is to miss its deeper truth. The moon is not simply with Earth. It has shaped Earth. It has protected it, balanced it, sculpted its rhythms, in ways so subtle yet so profound that without it the world might be unrecognizable. When the moon first formed, Earth spun rapidly, one full rotation every 6 hours. Winds would have screamed across the surface. Storms would have been vast and brutal, with hardly any pause between dawn and dusk. But the moon pulled at Earth's crust, tugged on its molten seas, slowed the spinning, not all at once, but gradually. Each pull, each tidal motion, acted like a brake. Today our planet turns once every 24 hours, and that gentle pace brings stability. The moon's gravitational embrace also steadied Earth's tilt. Without it, the angle of our planet's axis might have wobbled wildly over time. Some planets, like Mars, experience chaotic shifts in their tilt, swinging from upright to dramatically inclined over millions of years. These variations can lead to extreme and unpredictable changes in climate, but the moon kept Earth's tilt in check. Not perfectly fixed, but stabilized, like a spinning top kept upright by an unseen hand. And with that steadiness came seasons, gentle cycles of warmth and cold, of planting and harvest, of migration and dormancy. The moon gave Earth a kind of clock, and with it, Earth became a place where patterns could form, where life could evolve to trust the rhythm of time. Even now, the moon's gravitational pull moves the oceans. It draws the seas toward it, causing high tides that follow its orbit. As Earth rotates beneath that pull, the oceans shift and breathe in and out, like a slow planetary heartbeat. Long ago, those tides reached farther inland. They may have created the first shallow pools, wetting and drying in regular intervals. And in those pools, chemistry stirred. Molecules concentrated, bonds formed, structures emerged. Tides didn't just move water, they may have moved life forward. And as life evolved, the moon remained constant. In every age, every extinction, every rebirth, it circled silently overhead. When the first creatures left the sea and looked up, it was there. When the first humans walked the savannas, it was there. When we lit fires, sailed oceans, and watched the stars, it remained. Its cycles were used to track time before calendars. Its phases guided agriculture before science. Its eclipses inspired myth long before astronomy. And when we finally left our planet, when humans reached out into space, it was the moon that welcomed us first. We left footprints in its dust. We brought back samples of its stone. And in doing so, we touched not only the moon's surface, but the deep past we share. For the moon holds a record of time that Earth cannot. Here on Earth, weather erases, water erodes, plates shift and recycle the crust. But the moon has no wind, no rain, no shifting skin. It is a still book, and every crater, every ridge, every lava plain is a page in that book, unchanged for billions of years. To study the moon is to peer into the earliest days of Earth. It is our memory, floating in orbit. So when you look at the moon, know this. It is not just light in the night sky. It is Earth's anchor, its timekeeper, its cradle. It calmed the chaos, it steadied the storm, and it left just enough silence for life to emerge. Even now, as you drift towards sleep, the moon is still pulling, still watching, still moving the tides and measuring the dark. Its legacy isn't only in craters or orbits. It's in the breath of the ocean, in the rhythm of your day, in the balance of the world you live on, and in the way we still gaze upward, wondering. So sleep now, beneath its light. The moon is above you, constant, ancient, and always returning. It holds your past and cradles your dreams. So as you fall asleep tonight, look up. Imagine that glowing orb, not just as a light in the sky, but as a survivor. A messenger from a time when planets bled fire and gravity, ruled without mercy. The moon is not just pretty, it is proof. Proof that from impact can come harmony. That even shattered stone can become poetry in orbit. That even violence can leave beauty behind. Sleep now as the Earth settles beneath you. Let the moon guide your rest, as it has for billions of years. It will rise again, it always does. Chapter 6. Cooling Earth. The Earth has weathered the storm. Its surface, once molten and churning with violent impacts, begins to rest. Like a fevered body slowly cooling, the planet exhales. The bombardment has ended. The great collisions have calmed. And now the Earth begins a new chapter. A transformation from a world of fire to a world of water. Let yourself drift downward now, through the clouds of vapour, toward a surface that is changing with every breath. We are nearly 4.3 billion years in the past. The Earth's crust has thickened. Volcanoes still erupt, but less frequently, more rhythmically. Beneath the surface, heat still stirs the mantle, but above something new is happening. The sky is heavy with vapour, steam rising from the crust, exhaled from the Earth's molten past. And then, as the surface cools just enough, it rains. At first, the droplets sizzle on the hot rock, vanishing into mist. But it rains again, and again, and again, days, weeks, months, years. The planet is bathed in water from above. Imagine that sound, a world with no life, no trees, no animals. Yet the sound of rain is there, a gentle patter turning to a roar. It is not like rain today. These are the first waters, and they fall not just from clouds, but from deep within the planet itself. For much of Earth's water came from within, locked in minerals, stored in the mantle, released by volcanic eruptions and chemical processes. As Earth cooled, it breathed out moisture. Steam rose, condensed, and fell as rain. And perhaps comets played their part too, icy travellers from the outer solar system, delivering their frozen cargo in spectacular impacts. However the water arrived, by comet, by volcanic breath, or both, it began to stay. The surface, no longer hot enough to vaporize every drop, began to hold water. Pockets formed, then lakes, then seas, and slowly the oceans were born. These were not yet blue. The atmosphere was thick with carbon dioxide, methane, ammonia, and sulfur. The sky glowed orange, red, or even greenish, coloured by volcanic gases. But still, oceans spread, covering low basins, pooling around proto-continents, cradling the young Earth in liquid calm. Water, though soft and yielding, became the sculptor. It carved channels in the crust. It weathered mountains. It carried minerals from land to sea. And beneath the surface, chemistry awakened. Let yourself imagine standing on the edge of this early ocean. The air is thick. The sky glows strange hues. There is no life, no sound but wind and water. but you feel something in the air. Potential. The Earth is not lifeless. It is pregnant with life. In the deep places of the sea, minerals mix with heat. At cracks in the ocean floor, called hydrothermal vents, superheated water gushes into the cold depths. This water is rich in metals, sulfur, hydrogen. Here, in total darkness, chemistry stirs. These vents form chimneys of black or white minerals. They pulse with heat. They offer energy in a world without sunlight. And around them, the ingredients of life begin to assemble. But not yet. Not quite. This chapter is one of preparation. Let us return to the oceans. They're everywhere now, covering 70, even 80% of the surface. The crust is mostly basaltic, dark, dense rock. Floating above it, isolated land masses begin to stabilize. The first continents, small, fragmented, battered by tides and storms. But stable, over millions of years these proto-continents grow, accreting material at their edges, rising through tectonic motion. They are made mostly of felsic rock, granite-like in nature, lighter than the ocean floor. And because they are light, they float higher. Thus land is born, even if only small islands at first. These land masses break the vastness of ocean. They alter weather patterns, they introduce erosion, and they become the future cradles of life. Above, the atmosphere is changing. Volcanic gases continue to rise, CO2, SO2, H2O, NH3. But now, they're diluted by water vapor. Rain scrubs the sky clean of some toxins. Lightning dances across the clouds. UV radiation pours in from the young sun. There is no ozone layer yet to block it. But in this harshness, new molecules are forming. Organic compounds, carbon-based chemicals, begin to assemble in puddles, lakes, and oceans. Amino acids, lipids, sugars, the building blocks of life. Perhaps lightning catalyzes reactions. Perhaps ultraviolet rays power synthesis. Perhaps minerals on rock surfaces act as catalysts. There is no single recipe, only time and chemistry and patience. But again, that chapter is still ahead. We are still in the age of water, in the age of oceans. The earth is wrapped in a blanket of clouds. Its surface breathes through water. The crust fractures and shifts. The mantle convects beneath. The core spins, generating a magnetic shield. And the moon, still close in the sky, pulls on the tides. The rhythm of the earth has begun. Day and night cycle, tides rise and fall. Rain feeds the sea. Rivers etch paths through ancient land. The earth, though still dangerous, is no longer chaotic. It has cooled, just enough. Enough to preserve water, enough to build crust, enough to begin stability. And with stability comes the possibility of memory. Because water remembers, it holds heat, it stores chemistry, it connects everything. The same water you drink today may have fallen as rain 4 billion years ago. It may have filled a volcanic lake, or seeped into basalt, or risen from a hydrothermal vent. Water is the circulatory system of Earth, and it was born in these early days when clouds first formed and rain first fell, when oceans kissed the crust, and when the Earth, for the first time, felt cool against the sun. Let your breath slow now. Let the image of a vast ancient ocean fill your mind. No ships, no birds, no noise, only endless water, lapping gently against black volcanic rock, mist hanging in the air, the moon glowing faintly through a copper sky, and below, a world preparing for life. You are made from this water, you carry its memory in your cells, and even as you sleep, the oceans still sing, a song 4 billion years in the making. Sleep now, and let the waves carry you onward. In the next chapter, the sky will shift again. The first life will stir, and Earth will take its first breath. But for now, let the silence of ancient oceans cradle you. You are home. Chapter 7. Atmosphere and the Origins of Life. The oceans have formed, the rains have fallen, the crust has cooled into a patchwork of volcanic islands and fractured basins. And now the Earth begins to breathe. Not in the way we do, not with lungs or wind, but in a deeper, older rhythm. a planetary respiration, a slow exhalation of gases from rock, from sea, from sky. Let yourself drift in sync with that breath now. Inhale the silence of deep time. Exhale into the slow, molten heartbeat of the world. We are now around 4 billion years ago. The Earth is still young, but no longer chaotic. The surface has solidified into dark basalt plains, pockmarked with craters and scarred by the last dying embers of the late, heavy bombardment. Volcanoes still roar, great plumes of molten gas and ash tower into the alien sky. The atmosphere is thick, murky, choked with vapours. There is no oxygen yet, no ozone to shield the surface, no blue sky to gaze upon. Instead, a heavy veil of carbon dioxide, methane, ammonia, nitrogen, and water vapour hangs in the air, turning the sky into a burnt orange haze, streaked with volcanic ash and lightning. The sun above shines 25% dimmer than it does today, a weaker star, still settling into adulthood. And yet, paradoxically, the Earth remains warm. This is the puzzle of the faint young sun paradox, a dimmer sun, yet liquid oceans. The answer lies in the greenhouse gases, especially methane and carbon dioxide, that trapped heat and blanketed the planet in a thermal cocoon. It was a dangerous beauty. But below the waves, something extraordinary was beginning. Life. Not life as we know it. No fish, no ferns, no footprints in sand. There are no multicellular creatures, not even cells with nuclei. What exists here is primitive, molecular, and miraculous. The oceans of Earth are vast and rich, an alien sea, warm and acidic, tinged green by iron and minerals leached from the crust. It is here, in this vast chemical bath, that abiogenesis, the origin of life, may have occurred. Let us begin our descent. Far beneath the surface, where light does not reach, tectonic plates slowly pull apart. Here, along the spreading ridges, hydrothermal vents dot the ocean floor. Fissures where superheated water, saturated with metals and chemicals, erupts into the icy deep. This water is no ordinary fluid. It is infused with hydrogen, sulfides, iron, ammonia, and other reduced compounds, reactive materials drawn up from the mantle. As the hot fluids mix with cold seawater, minerals crystallize, forming towering chimneys, black smokers and white smokers, each pulsing with energy and chemistry. Around these vents, despite the crushing pressure and boiling temperatures, life finds a foothold. One theory suggests that life began right here. The vents provided the perfect conditions, a source of chemical energy, a gradient between heat and cold, natural compartments in mineral pores, like primitive cells. These mineral pores could have concentrated organic molecules, amino acids, nucleotides, fatty acids. The building blocks of proteins, RNA, membranes began to assemble in these protected spaces. Chemical reactions, catalyzed by metal sulfides and heat, may have sparked the first self-replicating molecules. Chains of RNA-like strands formed, not perfectly, but some folded just right. Some held the code to make more of themselves. And from this quiet chemistry came biology, the first protocells, tiny lipid-bound sacs enclosing genetic material, may have emerged in this darkness. They absorbed, reacted, divided. Slowly, the lines between non-living and living began to blur. Other scientists propose that life began not in the deep, but on the surface, in shallow tide pools, where evaporation, sunlight, rainfall, and lightning created cycles of concentration and reaction. Here, UV light may have driven the synthesis of complex organics. Clay particles may have helped align molecules into long chains. And perhaps, in one ancient storm, a spark of electricity danced across a muddy shore and gave rise to something new. We do not know the precise birthplace of life, but we know the signature: replication. When molecules began to make imperfect copies of themselves, copies that could evolve, life had begun. The earliest life forms were prokaryotic, single-celled without nuclei or organelles. They drifted in the oceans, feeding on hydrogen, iron, sulfur, whatever chemistry the Earth provided. They were anaerobic, they could not tolerate oxygen. They lived quietly, invisibly, but they endured. And over time, some began to change. They developed pigments, precursors to chlorophyll, that could capture the sun's faint light. These ancient phototrophs, perhaps akin to today's cyanobacteria, evolved to perform a revolutionary act. They split water molecules using sunlight, and in doing so, they released oxygen. At first, this gas accumulated in the oceans, where it encountered vast quantities of dissolved iron. The iron oxidized, rusted, and fell to the seafloor, forming banded iron formations, layered rocks of red and grey, still visible in Earth's oldest crusts. But once the iron was used up, the oxygen began to escape into the atmosphere, and that changed everything. At first, it was toxic. Many anaerobic organisms were poisoned by oxygen's presence. Its high reactivity disrupted their biochemistry, but some adapted. And eventually, new pathways evolved, ways to harness oxygen's power safely and efficiently. This was the first breath of what would become the Great Oxygenation Event, still far in the future, but already seeded in this moment. Meanwhile, the Earth continued to evolve. Volcanic eruptions emitted gases that helped balance the planet's temperature. Carbon dioxide was drawn down, locked into rocks and marine sediments through chemical weathering and biological activity. The once orange skies began to clear, the haze thinned, a fragile blue began to emerge at the horizon. And under this softening sky, life expanded. Microbes formed mats, dense colonies on seafloors and tidal flats. One of their most remarkable forms was the stromatolite. Layer by layer, these communities trapped sediments, building rocky domes, living fossils that we can still find today in places like Shark Bay, Western Australia. To touch a stromatolite is to touch a lineage 4 billion years old. They are the architecture of life's early chapters, built not of stone alone, but of persistence. As oxygen increased, it reacted with sunlight to form ozone, O3, a gas that collected high in the atmosphere and began to filter ultraviolet radiation. With this shield in place, life could begin to inch upward, toward the surface, toward the light, toward complexity. Let yourself drift now in those ancient waters. The seas are calm, the temperature is warm, the sky, still tinted bronze, flickers with distant lightning. All around you, unseen microbes float, divide, evolve. They do not know what they will become. They do not know you will carry their legacy. But they persist, and in doing so, they prepare the way. Every eye that will ever see, every hand that will ever build, every voice that will ever sing, all trace their origin to these waters, to these vents, these pools, these first breaths. Your very cells, your mitochondria, your genetic code, your proteins, are echoes of this ancient dawn. You are a living record, a walking archive of 4 billion years of chemistry and survival. Sleep now, as the Earth exhales. You are safe. You are part of a lineage older than memory. The world is not silent anymore. It is alive. And in the next chapter, it will rise from the oceans. It will grow continents, carve rivers, and stretch toward the sky. But for now, float in the warmth of those primal seas. Breathe with the earth, and dream of the first light in the waters of life. 8. Deep time, plate tectonics, and continents. Time stretches long behind us now. Billions of years have passed since Earth was born, since the moon formed, since the rains began to fall. Life has stirred in the oceans, and above it all the continents have begun to wander. Let us now enter the realm of deep time, time so vast, so slow, that the world itself becomes fluid. Mountains rise and fall, oceans open and close, continents drift like ice on a dark sea. Close your eyes now, and let the rhythm of the planet's breath carry you. This is the dance of the crust, the quiet, constant motion we call plate tectonics. The Earth's outer shell, its lithosphere, is not solid and unmoving. It is broken into great slabs called tectonic plates. They float atop the asthenosphere, a layer of slowly flowing rock deep in the mantle, driven by heat from Earth's core, these plates move, not quickly, perhaps an inch or two per year, but over millions of years, continents drift across the face of the planet. They pull apart, they crash together, they reshape the map of the world again and again. This movement is subtle. You do not feel it beneath your feet, but it is happening. Right now, as you lie still and breathe, the land beneath you moves, ever so slightly. To understand how this began, we return again to the early Earth. More than 3 billion years ago, the crust was thin, the mantle hot. Small protocontinents had begun to form, light islands of felsic rock floating atop darker oceanic crust. These islands drifted, collided, merged. Each collision created mountains, crumpling rock like cloth pushed together on a table. And over time, these crumpled fragments became the seeds of future continents. We call this process cratonization, the formation of stable continental cores, cratons, that would persist through eons. These cratons are still with us, beneath Canada, beneath Australia, beneath South Africa. They are the hearts of the continents, ancient, unmoving, silent. Around them, younger rocks accreted, chains of volcanoes formed along subduction zones, adding material. Sediments gathered along coasts, and the continents grew. By 2.7 billion years ago, plate tectonics was in full motion. The crust moved, the mantle flowed, and the continents began their eternal journey. Let your breath follow that slow drift now. Imagine continents like rafts, pulled by mantle currents, drawn toward heat, then repelled. Some plates slid past each other, others collided, still others tore apart. In these motions, the Earth found rhythm. Where plates converged, mountains formed. The Himalayas, the Andes, the Alps, all born from these collisions. Where plates diverged, oceans opened. The Atlantic, the Red Sea, the Great Rift Valley. The Earth's surface is dynamic, shaped not just by time but by motion. And through deep time, these motions created patterns. Supercontinents, great land masses where all or most of Earth's land joined together. The first may have been or perhaps Valbara. Then came Kenneland, Columbia, Rodinia, and finally Pangaea. Each supercontinent formed, lingered, then broke apart. Each reshaped climate, ocean currents, and the evolution of life. Rodinia, for example, existed around 1.1 billion years ago. It may have been centered near the equator, its breakup possibly linked to glaciations and oceanic changes. Later, Pangaea, formed around 335 million years ago, gathered nearly all land into one vast expanse. It was surrounded by a superocean, Panthalassa. But Pangaea too would break, birthing the continents we know today. These cycles are called the supercontinent cycle. They occur roughly every 400 to 600 million years. It is the slow heartbeat of the Earth. In and out, together, then apart. The mechanisms are complex, driven by slab pull, mantle plumes, convection currents. But the result is simple. The Earth changes, always. And with each change, life must adapt. Sometimes the collisions create mountain chains, new habitats for plants and animals. Other times, the breakup of land opens new oceans, shaping climates and coastlines. Every motion of the crust echoes through time. Even our modern world, its continents, its seas, its weather, is shaped by ancient collisions. The Appalachians, in North America, are the remnants of a mountain range older than the Atlantic Ocean. The Himalayas continue to rise today, as India presses into Asia. Iceland sits atop a spreading ridge where new crust forms even now. You are not standing on something fixed, you are part of something living. Feel that stillness now, and know that beneath it, the Earth flows. Let's look more closely at how plates move. At divergent boundaries, plates pull apart. Magma rises to fill the gap, forming new crust. These are mid-ocean ridges, the longest mountain ranges on Earth, hidden beneath the sea. At convergent boundaries, plates collide. One plate may slide beneath the other into the mantle, melting, fueling volcanoes. This is subduction. At transform boundaries, plates slide sideways. Friction builds, then releases. In earthquakes, each type of boundary shapes the land. Each has existed for billions of years, and each will continue long after we are gone. Imagine now the passage of 1 billion years. The continents shift. A mountain rises where once there was sea. A desert becomes rainforest. A glacier retreats and reveals a river valley. The land is never the same, and yet the rhythm continues. Plate tectonics not only sculpts the surface, it helps regulate the Earth's climate. As mountains rise, rocks weather. This weathering pulls carbon dioxide from the air, storing it in sediments. Over time, this helps cool the planet. When continents break apart, volcanic activity increases, releasing CO2, warming the climate. It is a global thermostat, slow but steady. It is this cycle of rock, gas and ocean that has kept Earth's climate relatively stable. That has made long-term habitability possible. And now, in the present moment, as you lie in stillness, the cycle continues. Mountains are eroding, new crust is forming, continents drift by centimetres each year. The map of Earth, so familiar today, is only temporary. In 250 million years, a new supercontinent may form. It may be called Pangaea Ultima, or Nova Pangaea, or something else entirely. But it will be different. The Earth is a storyteller that never stops writing, and its pen is made of stone. Let that thought settle into you now. You are part of that story. You walk on land that was once sea. You drink water that once flowed through mountains now lost. Your body is made of minerals that drifted through tectonic plates, that rose in magma, that cooled into rock. You are not separate from the Earth. You are its memory. Sleep now in the arms of ancient stone. Let the deep time carry you. Let the motion of continents rock you gently. The planet is not restless. It is alive. And in its slow breath it holds you. In the next chapter, we will close the journey. We will reflect on all that Earth has become, from stardust to oceans to life. But for now, rest beneath the drifting crust. The Earth turns beneath you. And so, another journey comes to a gentle end. Whether you're still awake or already adrift in dreams, thank you for travelling with me tonight. The universe is vast, full of wonder and sometimes full of silence. But here, in this little corner of the internet, we take our time to listen, to think, to drift. If tonight's voyage brought you peace or helped you learn something new, I invite you to leave a comment or simply a few words about what part stayed with you the most. If you'd like to join me again on future journeys through time, stars, oceans or atoms, you can subscribe. And if you'd like to gently support the channel, you can do so by visiting the links below. These stories take time, care, and a quiet kind of passion, and your support helps keep this space calm, creative, and ad-free. Until next time, dream slow, sleep deep, and remember, every star you see was once part of your story. Every atom in your body has travelled through time, and every question you carry is a map to the next voyage. I hope you enjoyed our Midnight Voyage. Until next time, good night.